When you're using Newton's laws and vectors, there's two ways of doing it. If you know which way it's accelerating, like a box along a floor or something down a ramp, what we frequently do in all the other videos you'll see is we make a free body diagram, we add up all the forces in the direction of acceleration and set them equal to ma and solve for a. It works very well. The problem is if you don't know the direction of acceleration. Like in this case, I've got something here, an object here, that's being pulled 12 newtons to the right, 8 newtons up, and 6 newtons that way. So that may be something looking from above, pulled in different directions. What's it going to do as far as acceleration? Well, because we don't know which way it's going to accelerate, I can't just add up the pieces in the direction of acceleration and say they're the only ones that matter. Everything matters. So really what I got to do is, I call it like the old-fashioned way, I have to add up all the forces on it as vectors, find out what they equal, and set them equal to ma. So let's do that. So F net equals ma. And what does F net mean? It means add up all the forces. And as I said, if it's on a hill, you can break it into components, and all you have to worry about are the forces in the x direction. But we can't do that here. So really, this problem is more about, can you add three vectors and then set them equal to ma? So I'm going to go through that part quickly. If you don't understand how I'm adding these vectors up, look at our vectors videos, and it'll show you how to add vectors. But basically, we're going to do this. We're going to say, we need 8. I'm going to call it north. I'm going to say that's north. So then this would become 12 east. I'm going to leave the units out of the equation because I don't want so many letters. This is north. We're going to call that north. That's east. So this one here, well, if it's 120, then that would be 90 here, which would make this 30 on this side. So we'll say south 30 west. So plus 6 south 30 west. So there are the three vectors I'm going to add. When I find that result, I can set it equal to ma. So how do we add up vectors? Well, as I said, look at the vector videos. Or we're going to look at it, it's 8 up, 12 to the right, and this is the one that we're going to have to break into components, this 6. This is 30 degrees, so I make a triangle and I break it up into my x and y. So it's down and to the left. 6, the opposite side is always the sine side. 6 sine 30 is 3 to the left. 6 cosine 30, 6 cosine 30, because the adjacent side is the cosine. 6 times cos 30 is 5.2. So when I add up vectors, I find the result in the x is, well, that has no x components. 12 to the right minus 3. 12 minus 3 is 9. I'm adding up all the ones in the y direction. That's 8 up minus 5.2, because that doesn't have a y component. This does, and it's down, so it's negative. So that is 2.8. So there are my two components of the resultant. I need to draw them and figure out what the resultant is. It's 9 to the right, 2.8 up. There's my resultant. Remember, the result is adding up all these. That's my net force. So how do I find the resultant? Well, I take this squared plus this squared, take the square root. That's Pythagoras. So the result is 2.8 squared plus 9 squared, take the square root. The result is 9.4. 9.4. I've rounded it off a bit. Now I need a direction because we have to know the direction of the acceleration. So how do I find direction? It's going to be east so many north. So how do I find that angle? It's the inverse tan of 2.8 over 9. So the angle is the inverse tan of 2.8 over 9. So the angle is 17 degrees. It's more than 17. I'm just rounding, keeping it simple. So 17 degrees. So the direction would be east 17 north. East 17 north. So my net force, which is the addition of all these forces, was 9.4 newtons. East 17 north, and that equals MA. So 9.4 east 17 north equals the mass, which was 2. So the acceleration, the direction stays the same. The acceleration is 9.4 divided by 2, which is 4.7 meters per second squared, east 17 north. And then if I wanted to add to this question, I'd say, how far did the object travel if it started from rest in 30 seconds? Well, that's just kinematics. And remember, this part leads to the acceleration, which we use in our kinematics formula. Okay, hope that helps.